Okay, in this video we're looking at stoichiometric calculations, specifically mass to mole calculations. So before you begin, please make sure you have the stoichiometry island handout that you were provided in class. So I want to go through and review the parts of the stoichiometry island. Remember that your known is going to be represented by substance A. Your unknown is substance B. So we will use A to represent the known, B to represent the unknown. So I'm going to go ahead just to kind of help us keep things straight. Remember that this is mass of A. This is going to be moles of A. On this side, this will be moles of B and mass of B, just to help us keep things straight. And then also remember, when we go between two different substances, we write a mole ratio as B over A. So let's go ahead and read the problem. How many moles of aluminum oxide will be formed from 12.1 grams of oxygen? So we have a balanced chemical equation here. So we're looking at the fact that the given is 12.1 grams of oxygen, so we can go ahead and identify that as A. Then it says how many moles of aluminum. So it's asking us how many moles of aluminum oxide would be produced. And so since that's what we're looking for, that is your unknown, and we identify that as B. We don't do anything with the aluminum, so we can cross that out just to make sure we don't use it. So let's go ahead and get the mole ratio out of the way, since we are going between two different substances. We're going from oxygen to aluminum oxide. So when you write your mole ratio, it's written B over A. So looking at this, we have 2 moles of aluminum oxide over 3 moles of oxygen. Okay, so we're going to use the mole ratio, so let's just go ahead and get that out of the way. Make sure we've identified our given and our unknown, and we have written the mole ratio that we will use later to finish the problem. So let's start off with the given, which is 12.1 grams of oxygen. So when we look over here, we're going from mass of A to moles of A. To go from mass of A to moles of A, you will divide by the molar mass. The molar mass of oxygen is 32. So I'm going to put 32 grams in the denominator and 1 mole in the numerator. So get your calculator, and what you'll do is you do 12.1 divided by 32. 12.1 divided by 32 equals 0.38, and our grams of oxygen will cancel to leave us with moles of oxygen. So we just completed the step that takes us from mass of A to moles of A. The next step is to go from moles of A to moles of B. And in order to go from moles of A to moles of B, we use a mole ratio. So I'm going to take that 0.38 moles of oxygen. I'm going to plug in the mole ratio. We wrote the mole ratio as 2 moles of aluminum oxide over 3 moles of oxygen. So let's go ahead and cancel out the like units, and so that way we are only left with the moles of aluminum. So you have your 3.8 moles. You're going to multiply that times 2. Excuse me, 0.38. 0.38 moles, multiply that times 2, and then you're going to divide by 3. 0.25 moles of aluminum oxide. So once again, let me summarize. The first thing you need to do is make sure you can identify your given and your unknown. Your given is A, your unknown is B. So 12.1 grams of oxygen was given, and it's asking us to find the number of moles of aluminum oxide. And again, I canceled out the aluminum because we don't use it in the problem. So looking over here at stoichiometry island, when we go from mass of A to moles of A, you're going to divide by the molar mass. And so what I did right here, I have your 12.1 grams of oxygen, and I'm dividing by the molar mass, which leaves 0.38 moles of oxygen. Now that I'm at moles of A, I can go from moles of A to moles of B. To go from moles of A to moles of B, you use the mole ratio. And your mole ratio is always set up as B over A. So 2 moles of aluminum oxide B over 3 moles of oxygen. So I take this mole ratio and I plug it into the second step of the problem. So we start with 0.38 moles of oxygen, which came from up here, the first calculation. Plugging in the mole ratio, 0.38 times 2 divided by 3. We cross out the like units and we're left with the answer of 0.25 moles of aluminum oxide.